So here is two examples of these perfect square situations. And I call them perfect squares because notice that I have like the x minus 3 squared or the x plus 2 squared. So anytime I have something that's of this type, the way that I'm going to solve it is eventually I'm going to want a square root. I can square root in order to undo that square. So first thing I need to do is get the thing that's squared all alone. So notice this is 2 multiplied by that. So I'm going to divide both sides by 2. When I do that, 2 divided by 2 is 1. So I'm left with x minus 3 quantity squared equals 28 divided by 2 is 14. So far so good. And it's tempting to try and like distribute this in or multiply this out, but the most efficient way is just to undo that square by square rooting. So next thing I'm going to do is square root both sides. So square root this side, square root this side. And when I square root, when I bring in a square root, remember a plus or minus comes in with it. Because this value could have been positive or negative and get squared to give me that 14. So, and then over here, squaring and square rooting undo each other, so I have this x minus 3 left. And now from here, square root of 14, I'm not going to be able to split up 14 any more than that, so I'm just going to leave it as square root of 14. And I don't have x all the way alone yet, x minus 3, so I'm going to add 3 to both sides to get x all alone. And when I do that, I have x equals 3 plus or minus the square root of 14. Here's another example over on the right. I'm just going to do it too. So I have 5 multiplied by this equals 30. So first thing I'm going to do is get rid of that 5. Get rid of on the left at least. Divide both sides by 5. Over on the left, 5 divided by 5 is 1. So I'm left with x plus 2 quantity squared equals 30 divided by 5 is 6. Next thing I'm going to do is I'm going to undo that square by square rooting both sides. So I'm going to square root this side, square this side. When I bring in a square root, plus or minus comes with it. So that undoes each other. So I'm left with an x plus 2 equals plus or minus square root of 6. I can't split up square root of 6 anymore. So now I'm going to subtract 2 from both sides. X equals negative 2 plus or minus square root of 6.